having looked at linear voltage regulators, now we'll look at switch mode voltage regulators, or switch mode regulation. Now, in those linear regulators, the excess voltage was essentially wasted. It was used across the transistor, dissipated into the environment as heat. And so switch mode regulators switch the output on and off very, very quickly. And they have a capacitor on the output that will smooth out that signal so that we don't see it going high and low, high and low, high and low, like a pulse width modulated output that we've been looking at earlier on. We've got something that the capacitor and often an inductor will actually smooth that out and act as a filter on there. And there's a few different types of these. You've got buck regulators, and they allow us to step down a higher voltage to a lower voltage. We've got boost regulators, so allow us to step up a voltage, so we can go, for example, from 12 volts to 24 volts if we wanted to. Or we've got buck boost, where we can go up or down. And each of these different ones has a different topology in how it actually looks, in how we, in the actual device, but how we arrange our inductors and capacitors and things. Here's a classic circuit diagram for a buck regulator. So buck, we're stepping from a higher voltage down to a lower voltage. And you see there's essentially two stages in this. One where that switching element or the transistor is closed, which we see in the middle there. And that's where the input's kind of directly connected to the output and is charging up the capacitor as a result there. And whatever we see, there's an inductor and capacitor on the output that's going to be doing smoothing for us. And we see our load there, our resistive load at the end. So that's going to be part of the cycle. And this may be toggling in the kilohertz sort of range or even faster. For the other part of the cycle, we open that switch, or our device automatically opens that switch more realistically. And in doing so, we've got a transistor there, we've got our inductor there, and we've got our capacitor there. And that circuit is then supplying the output to the load. So we're switching between the input supplying the output to the load to that capacitor supplying the output to the load. And in doing so, we get our different variable voltage out. Now that voltage, as shown here, will have a bit of a ripple in it. And depending on how much current we're using and what device we're using and what frequency we're using, we have different amounts of ripple. And generally we need some capacitors on here to do some extra smoothing on the output. Here's an example of a common one, a buck regulator, an LM2596. In this one you can have a V out from 4.5 right up to 40 volts. Now, because of buck topology, your input voltage needs to be higher than your output voltage, and these can supply up to 3 amps. The efficiency on these is upwards of 90% or something in that order. Our switching frequency, the rate at which we're switching at high and low, is 150 kilohertz. Now, you can get these in fixed modes, so you can have it fixed at 5 volts or 3.3 volts or whatever voltage you want, or adjustable ones where you have a little potentiometer and a voltage divider there that you allow, as you turn that, it'll increase or decrease the output voltage there. These are in a 5-pin package, and they basically get soldered directly to where the back pin is a ground pin as well.